And the screen is also visible? The screen
Yes,
is
sir, it's
visible?
visible.
Okay, okay. So we'll start with the, today we'll start new topic, obviously, dummy variable regression. And I believe all of you have got access to Google Classroom and the caselets. We have got 3 caselets, which I've thought that we'll refer to on this topic. You have got the access to caselets through Google Classroom. Yeah, Google Classroom. Yes, no.
Yes, sir, we got the case.
Great. Anything which you want to ask from the previous topic, regression analysis? You are doing assignment. I'm getting queries. So even if you want to ask something which you have not asked, you're welcome. Anyone of you, any question? So assignment will be over on 31st, and after that, as I go through within 2-3 days, I'll be able to go through all the assignments. And if I deem fit, I might have one Viva before I evaluate the marks, especially those doubtful cases. Now, doubtful means something which I am not clear just by going through your assignment, or sometimes performance is too bad or too good. So sometimes too good is also very suspicious how you have got such a great performance. So I'll just talk to you. So through your CR, you will be getting some invite for some interaction, maybe late in the evening, whenever you are free. And I guess that you will be free either in the morning or late in the evening. So your CR will be informing you, and we'll have quick 5 minute, 10 minutes interaction on Google Meet, and I'll have audio accordingly. So this exercise will also be over within 5-6 days. So by 7th, 8th November, I would have completely, I would have evaluated all the assignments, including this Viva portion. So you should be mentally ready to defend your work. In case I think that I need to interact with you, I'll be able to do that. So that is the additional information. One more thing, as I discussed last time, that the data set which you are having in your assignment is time series. So you can go for auto correlation test. Suppose this is one of the, I've just randomly picked one data set, and let me have something else. I don't use this. I was just working through with some data set. Suppose I have got the time series data of world indices of different dates. So let's say I pick just 3. And So these are the 3 time series I have just opened in my workbook. And as I run one regression, same thing which you will be doing in your case. Suppose I'm interested in BSE, Indian Stock Exchange, C, and then let's say all Taiwan and yeah, these two parties. If I just run one regression, I have got this. So this much is clear to you. If I have to go for autocorrelation test, so I can give, let's say you give a lag of 10, and here you are getting the results. So if you remember, I have already told you, but again I'll write it for you. The null for autocorrelation test. So as a matter of rule, when we have time series data, we should additionally check for autocorrelation also. Null is no autocorrelation. Alternate is yes, there is autocorrelation. So if I just show you, you just look at the first part. I mean, the beginning itself. Null hypothesis, no serial correlation. Serial correlation is another name for autocorrelation. So no autocorrelation or no serial correlation. And this is the F test, and this is the corresponding probability. Probability value is 0.000, which is less than 0.05. So when p value is less than 0.05, null is rejected. So null of no autocorrelation is rejected. Null of no autocorrelation is rejected. Alternate of yes, there is autocorrelation problem is accepted. So we'll say in this situation, autocorrelation problem is there. So this is the additional test which you can have. I'll show you in Stata also. Is it clear? Any questions? No question? Autocorrelation is clear?
Sir, we are not clear that why this test is needed in the first place. Means what is the issue in the data that the test is needed in the first place?
Which
That
test?
clarity is
Autocorrelation
yes,
or
yes.
all the things, whatever we have done in terms of diagnostic testing?
No, heteroscedasticity and multicollinearity is fine.
Okay.
This autocorrelation is new stuff, so that we don't know.
So what happened when we talk about autocorrelation? We'll be discussing, as I told you earlier, for timing, what we can understand is when we run the regression, we generate this error term. So in terms of when we are having normal y minus y cap, this is clear. We have got error term. And if we have got 1000 observations, so we will be having U1 cap to U1 1000. Is this clear? Yeah. Is this clear? Error term is clear?
Yes, sir.
So when we are saying error term, so what happened by the time it is time series, then these are not going to be the plain simple cross sectional, rather from time t1, you say time 1 to time 1000. So obviously, if it is days, it will be it is t1, it is t let's say n, or n is 1000. So what happened in time series data? The sample is nothing but the time. I repeat myself. In time series data, sample is nothing but the time. When I say time, it could be days, it could be weeks, it could be months, quarters, or years for that matter. So any denomination, time in any denomination will be there. So when I say 1000, it means, suppose usually this big number we will find with the days. Suppose I talk about stock market. Stock market usually in a year has got 250 working days. So probably I might be talking about 4 years, and that's why I have got 1000 observations. So this was a rough idea when I say sample in a time series data. So what happened when I say autocorrelation? To have the OLS, optimum least square method of estimation of beta j's, one of the basic assumptions that the covariance between ut plus k should be equal to 0 and k is more than 0. So this is one of the assumptions. If this assumption is not true, again, what happened? The OLS estimator will not be blue. As I have told you, this will not be a good estimator. Blue is nothing but best linear unbiased estimator. So the estimations will be questionable. So when I say questionable, I'm just giving you a slight amount of complexities only. The average value of all the estimated will not be equal to Bj, or as I increase the number of observations, in this case number of samples, Bj estimated. So Bj estimated should move towards actual Bj. So this is known as unbiasedness of the estimation, and this is known as consistency of the estimation. So when I say blue, then these two properties are inherent. In addition to that, we have got one more thing, efficiency. This is the efficiency. This says that the this error variance should be least. So heteroscedasticity was a problem related to something like that. So along with many other things, these are important features which should be there in blue. So if, as I have told you, three basic or rather more important or most important assumptions, heteroscedasticity, multipolarity, and autocorrelation. If they are not there, then these problems we come across. So, or in a way we say that OLS is doing the job of estimating BJs perfectly well only because the set of assumptions, including these three, are working. So error term should not have any correlation. So this is one of the assumptions on which OLS works. If it is not there, then these problems come across. This is not, but these two, unbiasedness problem or this consistency problem may come across. Is this enough?
Sir, could you just show the whiteboard again?
If we talk about the how to avoid this problem or how to have the basic problems removed from the whole estimation, in that case, if you have listened to me earlier also, I have talked that there should not be specification problems. When I say specification problem, any important variable should not have been removed or it should not be omitted, or unnecessary variable should not be in the estimation of regression. So basically, though these symptoms are different, heteroscedasticity have got different problem of having this which is not constant, the constant variance. Multicollinearity will be giving the false high R square because there are different variables. If you look at what is multicollinearity, so multicollinearity is covariance xi, xj should not be high. That is the idea. If you remember, I told you correlation will be there, but it should not be more than 0.8. That too significant. So if this is there, then we get usually very high R square, very high square, which becomes problem. So it gives a false association, which is actually not there. Similarly, if the data has got error terms are correlated, then you will have problems that the estimation, the unbiasedness and consistency both will be in problem. So solution of all these problems, including autocorrelation, is correct specification. But suppose you are complete with theory, you believe strongly, or your literature says that these variables should definitely be there in the system, then I have suggested to you to go for robust estimation of the regression coefficient. So that is a shortcut remedy. There are some long cut remedy, but that's also not foolproof. So best remedy to ensure that diagnostic testing is in place, that you try, hit and try, or you have a better theory which can have a better specification, and you will find that these problems will be automatically removed from the system. You were saying that, show me the whiteboard. I've shown you, didn't ask anything.
Sir, I was just noting down actually.
Yeah. No, it is. I'm sharing, all these notebook are shared on the Google Classroom. To show you, I'm sharing everything. Whatever I'm showing you in class, I mean during the discussions, I'm sharing with you. Go to the regression analysis in Google Classroom. You will find one of the folders, notebook PDF, and all the PDF date-wise are there.
Sir, do we need to request for access to access that?
No, Google Classroom, everyone is having the access.
So, but
there are two level access. Suppose there are something which I have kept on the drive, and I have given access to drive to all of you. So all of you can directly go to my drive also, the shared drive. In addition to that, I have given you access to, all of you still have the same access of Google Classroom. If I show to you Google Classroom, it is very nicely arranged, so that if look at here, the material introduction to FE, regression analysis, OneNote PDFs. All the OneNote PDFs are there. So far I have done 6 sessions. All the 6 session materials are there. 7th, I'll not be having here because I'm starting a new topic, dummy variable regression. I'll create one more folder and you will have it. I have shared the material of dummy variable regression, 3 caselets I'm using. So the caselet and their data is already shared with you. Study material, I thought that those who are interested, they can read. 10-15 slides are there. And I have intentionally kept very brief, small starter based tutorial or introductory tutorial on dummy variable regression. So whatever I'm discussing, the video, like videos of all the sessions are here in regression. 2, 3, 4, 5, 6. So I'm trying to arrange everything for you, and you can easily, you need not roam around or struggle. You can straight away come to Google Classroom. All the relevant material is shared. So if you are trying to revise something or understand or recall, you can very easily do it. But you have to at least come to Google Classroom. That I can't come on your behalf.
Hello, sir.
Yes.
Yes, sir. So for in autocorrelation, we try to estimate the error value for a particular variable over a period of time.
In a autocorrelation, what do we do? If I show you, in this, I have to yet to show you autocorrelation in Stata. So when we run one regression, this is the regression we have simply run. This is the normal dialog box you get. And then you have got residual diagnostic. There you are finding serial correlation LM test, one of the tests. And as you click it, ask for the lag. Let's say I'm giving 12 for that matter. Last time I gave 10. So what it is giving you, it is giving you estimation, but it is giving me the joint hypothesis. for all the lags, lag 1, 2, up to 12, it is testing, as I showed you here, UT and UT plus K. So one item will be testing for next time, next up to 12. So likewise, all the error term would have tested for their autocorrelation. And this is the joint test, which is giving me joint hyper this p-value. And if this p-value, as per the test of autocorrelation, null is no autocorrelation. If p-value is more than 0.05 or less than 0.05, then you reject the null. And if it is more than 0.05, then you cannot reject the null. So in this present case, what is happening that p-value, as I have run this autocorrelation test, is having a value which is 0, 0, 0. So it is less than 0.05. So if p-value is less than 0.05, null is to be rejected. So null of no autocorrelation has to be rejected. So there is a problem of autocorrelation that is interpreted.
Okay, sir. And sir, can you please speak more about lag? So what is exactly lag and why have we chosen the value as 10? So is there a reason behind it?
Lag is a this year sales. This year sales. Do you think that this year sales will be having some impression of the previous year's working capital or previous year's long-term investment? Will it have some impact on this year's sale? I'm asking you something. This year's sales, will it have some impact of the previous year investment, long-term investment, previous years of working capital investment?
So I think it should be the other way, like the previous year's investment should have a impact on.
Same thing. Previous year, I'm asking you, previous year's investment will have some impact on this year's sale?
Yes, sir.
So what is happening? This is having the lag. Suppose I try to find out association on today's sales with today's working capital, then it might be having some issue. Rather, if I find out today's sale having some association with previous year of working capital or previous years of long-term investment, it will be more significant association. So it means there is a lag effect of working capital or long-term investment on sales. So that is one of the examples of when I say lag. So what happened? There are different features where impact of something is seen not today, but in the future values. So this is whatever way you look at on today's impact, the previous values are having influence. So that is what we call it lag. So if previous year is 1 lakh, previous to previous year is 2 lakh. That is the idea. When it comes to time series, so I can say in time series, let's talk about stock prices. What do you think that stock prices should have any lag effect or not? In a way, today's share price will have some impact from the last days or last week's share price, last to last week's share price. Will it have some impact on today's share price? It should be or it should not be?
So actually it can depend, like a company's current policy may affect the share prices.
It's just a matter of 2 weeks. Policies will have impact in years or quarters. I'm just saying today, yesterday, day before yesterday.
I think I'm not quite sure about it, but it may have an impact, sir.
It has. There are many theories, but usually you will find that the previous day, previous week's share prices are having the impact. I give you one more example, like Indian stock market, US stock market. So whatever is happening in the US stock market definitely have some lag effect on Indian stock market. When I'm saying this, I will be showing you with the help of data. So let me move to the topics in the course. I'll demonstrate to you as I move to next topic. After this, we'll be having ARIMA, which is univariate. And as I move from ARIMA to VAR, vector autoregressive model, I'll show you bivariate or multivariate models. Then I'll demonstrate to you how different stock markets might be impacting the another stock market, or how Indian stock market is getting impacted by other stock markets. What is the percentage of impact, that also I'll be able to show you. So everything can be very much visible as I go through showing you the models. So you were asking about the lag. So there is always some lag effect. So what happened when we go for assumption of OLS of autocorrelation nature? So it says that the error terms what we are getting, this should not be impacted by the error term of previous term or previous term. What happened? Error terms, I'm giving you one more technical term, white noise. The error term, these are the error term, should be white noise, or in a layman's language, we say random. So when I'm saying that this error term should be random, so this is the assumption. And just to prove this assumption, I have to say that it means what is the implication of having the random error terms, that correlation of error term with the previous error term should be 0. And if it is this type of situation is there, then we can say that error terms are having the random tendency. So I'm practically trying to prove that my error term is random. It is not getting impacted by previous values, and it will also not be able to impact the future error terms. So that is the assumption, and that is what we are trying to prove. So lag means when I'm having, let's say for argument's sake, my time series is weekly. So what I am saying that the error term of first week, error term of second week, error term of third week. So if I just randomly pick, let's say the third week error term. So what this assumption of OLS says that this should be independent. This should not be having any impact with the previous values, and this will not be able to have any impact on the future error terms. So that is what assumption is. And these are the lag values for them. For this time period 3, time period 2 and 1 are the 1 lag. This is 2 lag. And likewise, I can have more lags. I hope the point is clear. So
Yes,
lag
yes.
is a general term, but if you are having weekly data, then the previous week is 1 lag, previous to previous week is 2 lag. I have quarterly data, then previous quarter is 1 lag, previous to previous quarter is 2 lag. Likewise, year, fortnights also. So lag, the previous time period is the lag for a current time period.
Yes, it depends on the time period, the sample which we evaluate. Okay.
So general, I cannot make any generic statement. I have to say whatever is the time period of your time series data.
Sir, I have a question. The lag period which you specified, on what basis did you get that number? And second question is
Which
that
number? No, first question was which number?
The 12 which you specified in the lag.
What happened? You think using your common sense. See, this year's sales will have some impact from the previous year happening. Something happened which previous to previous year. What had happened before 10 years probably will not have any direct consequences on this year. So we take a reasonable length of lag and then we'll say good enough. There's no point of testing. How long can you test? So whatever your common sense is, common sense prevails all the time. So that is the only logic of putting. Sometimes people use 24, 36. These are the general ways to test for the lag. But that depends. If I'm having daily share price, I would like to know, then probably 36, 24 is not a big number. But when I'm having weekly data, probably they are big number. Or when I'm having monthly data, they are the big number. 4 years before what is going to happen today. So likewise, we take a call, what would be the appropriate lag length, and accordingly we randomly check. There's no hard and fast rule for that.
Okay, understood, sir. And my second question was, in the assignment which we are given, will we also have to assume some lag while specifying the model?
Time series, only you have to test for autocorrelation. Go for, you are using yearly data. So I think 2-3 lag will be good enough. You are having yearly data, no?
Yes, sir.
profit data for last 15, 20, 25 years. So 5 is good enough. Lag 5, that's it. And you are not testing lag anywhere else, are you?
Yes, sir. It's only relevant in autocorrelation. actually.
Autocorrelation. Go for 5, good enough. 5 years, previous 5 years impact on today's error term, good enough. So there are many students who are not asking, they must be, getting bored. They're saying why we are talking this and that. Half an hour we have spent.
Hello, sir.
Yeah, Nick.
So
Yes,
you said you would be explaining the autocorrelation on Stata as well. So
I'll right now I'll show to you.
yeah.
Any other question? I'll tell you one. Yeah,
Just
yeah,
that.
Nick, yeah. Tell me.
No, it was just about that.
Okay. I'll give you one, knowledge, tacit knowledge, you can say. What happened that when we are beginning with the data sciences, in the very beginning, we are lost in software, this software, and we become master of one software or two softwares. And that gives us a false sense of control over the data analysis. But that's not reality. Understanding of or comfort with one software is nothing great. Always have conceptual clarity. This understanding comes, even many people still don't understand. Trust me, with full authority and experience, I'm sharing with you. So, a good person, a few, let's say 10% of you might have more interest in data analytics. So, for them, probably this understanding may be of use. That try to develop the conceptual clarity, because that is the real understanding. Software will give you a false sense of understanding because there is no end to software, and software will not give you much beyond a point unless until you are clear with the concepts. So I'm not discouraging you to have good hold over the software, but that is not the end of it. And knowing software, like anything, has got a limitation. It's okay. It will give you a false sense that you have understood the course or statistics or econometrics. But understanding the concepts is always 10 times more important than developing the comfort with the software. That is just a passing comment or understanding of software versus knowledge. So that's why you might have noticed every time whenever I talk, I insist that we should pay more attention to the conceptual clarity of the concepts. You will realize that there is no end to software, but software knowledge is very limited. So that's end of it. I'll quickly show you how to. So
Sir,
same data. Please go ahead.
Sir, is there any significance limit for autocorrelation? Like I just lost you in between, so I don't know whether you told or not.
Significant limit means? I could not understand your question. Vaibhav, please. Yeah, tell me. Vaibhav, are you there? Surely, no issues, he will come back. So we were talking about using Stata. I'll use the same data set. Vaibhav, are you back?
Hello, sir. Am I audible?
Yeah. Tell me.
Sir, like significance limit, sir, is there any limit between the serial correlation or something? To be very precise.
I'm still unable to understand what you are saying. Number of lags.
Sir, I think what he wants to say is that we use a 0.05 as the level of significance for other tests. So I think that is what he's asking.
5% level of significance is in between. And we have two more popular level of significance, 1% and 10%. But they have their own approach to handle. So they are extreme cases. So it is always preferable to stay in the middle and go for it. 5%. So in extreme cases, right now you don't have any extreme case. As and when we get any extreme case, we'll talk about level of significance. Anukamini madam would have by that time definitely shared with you. Has she come to the inferential statistics or still she is completing the descriptive? Has she
Descriptive
started
also,
testing
sir.
of significance? Hypothesis testing?
No, only
So
descriptive
she
statistics.
will give you in detail. I'm only picking those parts from everywhere which is of use for me. So for me, 5% is good enough. As you become more wiser in my course or some other course, I'll give you idea when and how you are supposed to use 1% or 10%. So don't you worry. As and when I get the utility, I'll definitely share with you. But as of now, we don't have any utility. We'll stick to the middle path of 5%. Done? Yes or no?
So the command for autocorrelation test in Stata.
Yeah.
So
So what happened when we are running the time series in Stata? So what happened? We have to first of all tell to Stata. If you look at the data set, what we have just opened, this. So I just use BSE Singapore, Taiwan stock prices of different dates. And I have to intentionally create one more variable if I want to use time series in Stata. These are the time variables. So T period I have just shown. So this data is 2003, 7 something like that is there. So 2007-03 observations are there. So I've just created a time variable that has to be created. And before I run the autocorrelation test or time series, apply the time series test, I have to tell to the system that TS time series set. And I have to give the idea about the variable which I have created for time. So T set, T period, I have to tell to the system that my data set which I'm going to use is time series. Otherwise, if you remember, yes, last time when I was running the B Godfrey test, autocorrelation test, it was not taking. So I had to tell to the system that there is a time series data. I repeat, TS set. TS set is the command, and whatever is the time variable which you would have created in your data set has to be put. Our system knows that we are running the time series. Right now, I can run regression. Let's say I still go by the same regression, BSE with Singapore and Taiwan. And I just run the regression and I can test still heteroscedasticity, multicularity, all those things. Similarly, I can start E-start and B Godfrey. Not F-R-E-Y, I guess I remember spelling correctly. Yeah. So B Godfrey test E-start. E-start B Godfrey. This is the name of the test which we use for autocorrelation. Everything remains same. Everything means the pair of hypotheses remain same. Yeah. This is the pair of hypotheses. No autocorrelation is the null. Alternative, there is autocorrelation. And as I have run, this is the p-value for this autocorrelation test. And in eViews also, we were getting the same issues. This was the p-values were 0.000, and here it is 0.00, or null cannot be rejected. Null is rejected, sorry. Null is rejected in both the cases. So null of no autocorrelation is rejected. It means no autocorrelation is not there, rather there is autocorrelation problem. So this is the way by which we handle the autocorrelation issue in Stata. Is it okay?
yes, sir.
Just quickly give me, I can't go for any voting here, but just tell me, how was your level of understanding with this regression? Because regression is the basis of every other thing which we are going to use. So I have practically invested 5 sessions on regression. So I believe that I have tried to go as slow as possible so that you can grasp the concepts of regression. So I believe, how is your level of understanding? Do you still feel comfortable when you do your assignment that you can do it, or you struggle to do that? What is one of you? I mean, at least a few of you, please react.
Yes, sir, we were able to do.
Pranay is positive. Others, some
Sir, there
critics.
is one or two doubt. Uh, the variables like sales and the total income were going insignificant, and also they were having high collinearity with the PAT. So,
No. Collinearity with PAT is not important. Collinearity is important among the independent variables. Though we run
okay,
all of them together, but collinearity issue is there when you are having a high degree of association of more than zero point 0.8 significant among the independent variables.
so, but the problem was happening was if we were using variables like sales and the total income, the VIF was going way above 6.
Then
Though,
check the
though it was not, though it was not having any connection with the other variables.
in the correlation coefficient.
Yes, sir.
So you can go ahead, no problem. If I remember my discussion, I told you the most important thing is the basics. And
Okay.
the basic theory of multicollinearity is very strongly says that this is the significant correlation of more than zero point 0.8 is the problem. So even if
Okay.
VIF is secondary, if you remember my discussions, I said VIF is secondary, supportive argument, not the primary.
Okay, sir.
Primary is basic, that is the correlation should not be more than zero point 0.8, that too significant. So you
Okay, sir.
can go ahead, that can be ignored. Report that it is
Got it, sir.
coming more, but correlation is not there, significant more than 0 0.8, go ahead.
Okay. So also on the similar basis, it is also the R square is also going way above 0.98 something due
So
to
usually
sales.
when you get such a high R square, it is happening because of usually multicollinearity. So you have to, glean through correlation coefficient very seriously, whether it is significant or not. And if you are confident you
Sure.
haven't done any calculation error, then you go ahead. Ultimately what your data says you have to believe. And if your data
Okay, sir.
is correlation is always between two variables. So there is no, discussion of any third thing coming to picture.
Got it, sir. Got it. Yeah.
Done. Still, if you have any doubt, you can bother me. You guys have my WhatsApp number, and if I need, I ask you to call me also. So feel free in clearing your doubts. So that is what I can do, and I have tried to keep the pace as slow as possible, so that despite these concepts are slightly tricky and difficult, I've tried my level best to make you understand. Still, if you have doubts, you are most welcome. Offline also, you can get back to me. So I'm starting a new topic, dummy variable regression. So I'll give you first of all utility. Why at all dummy variable regression? Have you ever found, let's say, GDP? India opened up its economy in 1991 when Manmohan Singh was finance minister and P. V. Narasimha Rao was there and all. So what happened? During those days, the policies were changed. And then people say that that was the time when our GDP significantly changed from a poor shape to a good shape. But this is just a statement. Suppose I want to prove this point, yes, the GDP growth rate or GDP, mathematically you might look at that before 1991 it was 4.5, 5.6, something like that. And after that, it has kept on increasing to a good level. But how to verify this statement? Anyone, any suggestion? Simple example I've taken. Country's GDP 1991 before 19 after 1991, and I want to prove this. And open a statement that India would have changed after 1991, but prove this. How can you prove this? Anyone? Common sense. Use your common sense. Tell me the method by which we can prove or disprove. No, it's not reality. That's not truth. And I would very strongly appreciate all of you to take part in the discussion. Class is not only for a few. Yes, react.
So by collecting data and calculating stuff like per capita income like that before 1991 and after 1991 to understand that what impact had the
How will
policy had.
you prove this? Data is all the way there of GDP also, GDP growth rate also, per capita income data is also there, and it is some change. But is the change good enough to say yes, country has got completely changed, or there is something else to be required? How will you verify these statements? Just numbers speak for itself, and that's it. Just because numbers have got changed, you will believe that yes, country has really changed. Is it enough, or scientifically we need to do something else?
So maybe check the consistency of the growth.
How? Question. How? Look at the growth rate. Consistency, you will find that there are some changes positively. Is that good enough? Or something else should also be done? मैडम क्लास में बाद में बात करूं? हाँ मैम क्लास में हूँ मैं. Yeah, please tell me. Sorry. Please tell me, is there any other method by which it can be done? Come on. I'll give you one more example. Suppose you join a company, let's say in 2016. 2016, some new CEO joined a company and he says, let's say after 3 years, he says that just by the day I have joined the company, I have completely transformed it and there's a significant change in the sales of the company. Or he says that he would have ensured that the cost has significantly gone down monthly. And he has got monthly sales or monthly operating cost figures. He's having 2016, let's say he joined in October 2016. So October 2016, before and after, from October 2016 onwards, monthly sales and operating cost data he is having at his disposal. And he's looking at the data and he's saying, look, there are some changes. Is that analysis good enough or something else is also required? Question for you. Because we are now, behaving like a data scientist. We are playing with data to use data to come out with some meaningful information which can be used in management for the betterment of the company. Come on, I'm giving you two.
Sir, I can just take a guess, but I don't know how much right is this. So,
Now, you
sir,
should
if we are
expand your
saying,
mind, yeah, I'll
if we are
appreciate
saying that the cost has decreased, we need to first see where the cost has decreased. Like if he's saying that operational cost has increased, so where is that where did that decrease came from?
that is not the point. There is a reduction in operating cost, but is the numbers are enough or something else should also be done to verify the numbers? Tana was saying something. Yeah, please go ahead, Tana.
Sir, can we compare it with the other companies in the same industry to get an idea of whether the numbers are correct or not?
That's okay. I'm not saying no to it. It can be compared. But what happens that every company is unique in itself. And when CEO is saying that when he has joined, he has changed it, then you have to pay attention to that company only, at least for time being. Because that CEO has joined that company is saying that I have brought the changes in operating cost or I have ensured that the sales have gone up. And numbers are supporting him. But is the numbers enough or something else should also be done to verify these statements?
So maybe try and check the kind of policy changes that the CEO has bought in and
Policies
then
have got changed. Policies have got changed, but change of policy is not everything. Data is also supporting.
Sir,
But is the change of data or positive change in data is good enough or something else should also be done? I'm bringing
So
the
maybe
point home is there some
with past right?
statistical or econometric or data science test which should be applied before being judgmental on this?
check whether there is a relationship between the policies and the growth that has been accrued.
mainly study whether the same growth would have been achieved without considering the changes?
How will you simulate that?
So comparing the past performance, as in we can find the year on
Comparing the
year,
past performance with the
comparing
future.
year on year, maybe increase in the
Now we are
percentage
talking
increase.
sense. Now we are trying to find out solution with the data. Please understand.
So
Now
like
Kanai is approaching towards that situation where he's trying to find out solution with the data. And
so
yes,
like a
data
trend
has got some
analysis.
solution. And again, I'm not saying that this is end of it, but yeah, data has got some methods which can help to verify the claims. Such claims can be verified, and one of the application is dummy variable regression. I repeat, whenever you have got, let's say, a point of inflection, and you have got something before that and something after that, and you want to know what has happened, whether this change is significant or not, that can be answered. This question can be answered with the help of dummy variable regression. So this is one of the applications of dummy variable regression. If I try to give you more such situations, then um, there are many situations like every time some point of inflection has to be artificially created, and you have to figure out. Let's say I'll give you one more application. So I'm trying to give you applications of dummy variable. Then I'll show you the applications. Let's say I'm saying that India in a company can be divided into 5 zones: north, east, west, south, and center. 5 zones, and I want to know whether the north sales in north is better than others or not. Sales in east is better than in other zones or not. And if it is better, then what is the change? What is the difference? What is the difference in north as compared to others? What is the difference in east as compared to others? By how many points north is more than east? By how many points north is more than west or more than south? All these things can also be done with the help of applications of dummy variable regression. When we have more than one categories, if you pay attention, right now we had only 2 categories, before and after. These 2 categories, but here what we are not having 1 or 2. Here we have got just 1 and 2. Please pay attention when I'm saying categories. For me, before and after are 2 categories. And here I'm saying that I have got 5 categories. So 1, 2, 3, 4, 5. So for a data scientist or somebody who deals with data, he will say that whether the situation of 2 categories or more than 2. First of all, why I'm saying 2? Because by the time we don't have 1, then we have not univariate but bivariate. And this is the situation of multivariate. This is bivariate. And this condition, when we have got only when there is no 2 category, then we are talking about univariate situations. So what is happening whenever we have whether 2 categories or more than 2 categories, and we would like to compare, then you will find that dummy variable regressions comes handy. So whether you think in terms of having India 5 zones and you want to compare whether one zone is performing better than other zones, one zone is performing by what percentage better than other zones, that type of questions can be answered with the help of dummy variable regression. Or as I told you, the situation where we have before and after, and only 2 categories are there. We want to compare whether one category is better than other category. So before and after is something of that type. But before and after, you would have many such occasions where you would like to use something and dummy variable comes into picture. Anugamini will teach you something known as t-test. T-test is also one application which comes handy, but t-test only test means. So t-test can be between before and after. Whenever we have before and after, you will find that this t-test can also be applied. So there are some occasions where these t-tests might give you some idea, but dummy variable is always most promising approach to solve even before and after cases. T-test is also limited with the 2, so only bivariate cases can be handled. You may not understand what I'm saying when I'm talking about t-test, because somebody has to teach you t-test. And if you know beforehand, it's good. Otherwise, what I'm saying that dummy variable application of 2 categories can be compared with the t-test to solve such problems where I said before and after 1991 or CEO came into picture in 2016. So those cases can also be solved with the help of t-test. But as compared to t-test and dummy variable gives you much better results, or more authentic, more strong results can be seen with the help of dummy variable regression. So anything which you would like to ask so far? So dummy variable is a tool which can be applied in such cases to solve the problem, to answer the claims. So we will go to the caselet, dummy variable regression.
Sir, I have a question.
Please go ahead.
Is dummy variable regression used only for binary data?
I guess I explained to you that dummy variable can be used here when we have 5 categories. But the style of solution will change as we have multivariate. But as long as we have bivariate cases, we have simpler solutions like before and after. But this does not mean that we can't apply dummy variable application when we have more than 2 categories.
Okay. And because I was reading some materials, so in that they were making it into mutually exclusive categories, and they were using only 0 and 1. So I was wondering if it was the only binary.
Dummy variable is binary, but it can be applied to multi-category situations also. I'll show to you. So what you studied is not wrong, but application of dummy variable can be done on the multi-category situation or multivariate situation as well. Right?
Okay, sir.
Yes, anyone else? So please read the caselet, hardly half of the page. What is happening? There are study of cars, 54 cars are there, and these 4 things would have been gathered. Their price, cost per mile, and road test score. It is measured on a scale of 10, and value score from customer, how much value people, those who are using the cars, they are giving. So the study was done on 4. I'll show you the data so that yeah, here it is, the data. So I guess data is clear to all of you. So these are different car brands. As I've told you, 54 is there. Sizes you can ignore. Price is there, all in dollars. And you have got dollar per mile cost. And then you have got, so basically these 4 are the variables, these 4. No, the other, they are dummy variable we have created. I'll tell you how to create. So these are the 4 variables gathered in this caselet. And what is the issue? What people are saying, suppose I'm the analyst, what I'm saying that these road test scores are calculated when some competition or some exercise was conducted on the road, and road testing is done among the simulated environment, some given conditions, and then roads were, the cars were supposed to go through those phases, and their scores were calculated, and that score is there in front of Let me correct myself. I think that if I go for minimum maxima value, test scores are on the scale of 100, I guess. And if I just calculate minimum maxima, I'll be better off to tell you not on the, that's not on the scale of 10. Just let me quickly get the data. So here we are, dummy variable, caselet, cars, and first, yeah. Here we have, if I just go by road test scores, then minima is 52, maxima. So these are the denominations, and value score is 0.8 to 1.99. So these are the scales are not specified. So I don't want to make any comment for which I do not have the data. So what is said that people are making some claim regarding this caselet, that the road test scores really make any difference in the pricing. The meaning of this is people may claim that if the cars are costly, they are sold at premium price just because they have got very high road test scores, or the customers value them high. So people want to know, is it true? Is it genuinely happening, or it is that there is no association between high or poor road test scores and the price? So prices are reflection of the performance, or prices are based upon certain other thing which are not, at least not done in this case. Suppose that type of claims are made, and we were asked to test. Let's say we'll start with the road test score. Let's say somebody is criticizing that road test scores are only a marketing gimmick. It has got no impact on the price. If the cars are having good score, but price has got nothing to do with it. So do you think that this will be a fit case to test? Do you think that we should test, or shall we go about testing the situation that high test score and low test scores are having any impact on the price or not? Maybe test the situation, yes or no?
Yes, sir.
Suppose we go about testing the situation. So one of the method to test this is that if you remember, we were talking about median. So when we say median has got a tendency. Let's say we talk about road test score, and obviously we would like to know what is the median test score, road test score. And if we try to prove that the test score which are coming below this and above this are having significant impact on the price, then we will be able to either corroborate, support the argument that difference in road test score is impacting the price. And if we find that the road test scores which are before and after, they are not having any significant impact on the price, then we'll say that road test score has got nothing to do with the price. So performance of a car on the road has got no impact on the price. Our price is not a reflection of the performance of a car. Are you with me? Are you with me? What
Yes.
I'm saying that I am dividing the test score on the basis of median. And what I'm saying, I'll call scores of road test score before medium as 0, as Nishant was talking about binary. And I will give all the cars having their test score more than medium as 1. And I'll run one regression of this nature. We'll run the regression like this. I'll put the price as the dependent variable as a function of dummy variable a road scores RS. So dummy variable road scores, or if I just use a more simpler form, price is equal to beta 0 plus beta D RS into D DVRS. And if I tell you, these are the coefficients. This is one coefficient, This is another coefficient. They are nothing different than this beta 0 plus beta 1 x1. What has happened? This is nothing but beta 1. This is nothing but beta 1. And this is nothing but x1. And x1 is dummy variable. X1 values, if I show you, then it is either 0 or 1. 0 value means the road score is less than median, and 1 is that road test score is more than median. So median is just a cutoff inflection point which I wanted to use. That's it. No other role of median as such. But I just want to know if I compare the price before and after median of the road test score, and if this value, this is the coefficient of dummy variable. This is the coefficient of dummy variable. I'll test for my generic form of testing of coefficient in any regression is beta j is equal to 0 always consider. So this dummy variable coefficient will also be tested for whether it is 0 or not. And alternate will be beta dummy road score is not equal to 0. This is the hypothesis I will be checking. And I'm giving you the idea about the judgment. If this null is rejected, if null is rejected, so my conclusion will be there is significant impact of road scores on the price of the car. So I don't know what is going to happen. I have to test it. Only then I'll be in a situation to support the statement which I have just written. So what I'm waiting for null to be rejected if I really I'm support of road test score should, and this is my claim that road test score has got significant impact on the car price. Means cars are priced high if the scores are high, and I just want to test this. So if I want to support this, then I look forward to that this coefficient should be significant or it should be non-zero or null should be rejected. So I can do that, but to do that, I have to first of all create the dummy variable of this nature, and then I have to run it. So this is one of the applications of dummy variable. So before I start doing it, I want you to react to it. Have you understood the problem and the solution? What we are doing, mathematics is only a matter of clicks that I'll do, no problem with that. But concept, have you understood? So dummy variable regression will have a regression where one dummy variable will be created of some definition, the way I have just defined it. I'll give some values 1, I'll give some values 0, and then I'll have one dummy variable. And I will run the regression for the concerned variable as dependent variable and dummy variable of concern as independent variable, and I'll look at the coefficient of dummy variable whether that is significant or not. When I say significant means I'm saying that it should be non-zero or the null of 0 should be rejected. I want that null of dummy coefficient of dummy variable to be rejected to have the meaningful impact of the dummy variable on the variable concerned. Right now my dummy variable is having high and low road test score. That is what my dummy variable is. And my relevant variable which is of concern is price. And I'm trying to test whether high and low levels of road test score is having meaningful impact on the price of the cars or not. And that's why I'm making application of dummy variable regression of this nature. Are you with me? Yes?
Yes, sir.
Sir,
Yes,
I
sir.
have a query.
Please go
So
ahead.
we could have done this analysis without using a dummy variable also, right? We could have done the normal test of significance and found out whether the variable is
T-test
having
is
a
also a type
significant
of
impact.
significance. T-test is also a type of significance test. What does t-test do? T-test will calculate the mean value of before, all the cars, their prices will be calculated. and a mean will be calculated where test scores are more than a median. One set, one mean, and then all the cars having the test scores less than median will be put together. Their prices will be added and mean will be calculated. So I have got two means. One mean of those cars which are having their road test scores more than median, and another mean of all the cars which are having their road test scores less than median. And then I'll compare their mean values and I'll find whether the comparison, the difference between two is significant or not. That is the application of t-test. That is also one of the applications. Right now I shared with you that binary or bivariate dummy variable applications can also be done with the help of t-test. But if you compare dummy variable application for bivariate and t-test, you will find that dummy variable applications will give you more stronger results as compared to t-test. I hope I have answered your question.
Okay, so the whole idea is to classify into two separate sets of data and then compare the.
But in t-test, we go for t-test is t-test of means. But the regression is not a t-test of means, rather it's a continuous variable test. It's a parametric test. So t-test is also parametric test, but parametric test of mean. So that is the difference. It has got limitation that compares the mean only. Regression compares, you can have in this application some other exogenous variable also. It is not that only dummy variable can be there. Means you have got price, you can have cost per mile as the exogenous or independent variable, and then you can have dummy variable also. It means in this regression, you are not only having the impact on price of dummy variable, but another exogenous variables also. On the contrary, when we talk about t-test, there is no such facility. So there are many such arguments which can be told in support of application of dummy variable. It's not that we are talking dummy variable, so we are supporting it, but dummy variable has got its own very strong applications.
Okay, sir.
So I'll try to show you how it can be done on EViews. Not a problem. You know, here what I have done, I'm just showing you this. So this is road test. Yeah, this is the road test score. Yeah, this is. So if I just median value I have calculated, I'm using Excel. I'll show you how I use the softwares also. So I have just run command median. Look at this command median of this. This is for and this is the road test scores. Road test scores are there. Median I have calculated and median value is coming 78. So I have just calculated, this is the variable of interest for me to make the dummy variable. And then what I did, I use just if command. If command, if you look at if command, some of you, it should be just a GK, you know, using Excel should be as good as, you know, speaking a language. So this is just one, I'll show to you how it is applied. Like if I write if command, if I write, and whatever logic I want to give. So my logic is, if this road test score is more than 78, I have given median, then I want that it should be 1, else 0. You can follow if, this is if, close the bracket, enter. And I need to just drag it. The same thing I have done, I have dragged it. So I've given the if command, if E4 is more than this I12, and I have just given the constant referencing so that when I drag it remains same. And accordingly, I have just given 1. And if it is not, then 0. Same logic which I used here in this I2. So this is the road test score. This is one of the ways. If I have to do this, I need to how many? 54. So if I have to apply this in eViews, it's very simple. So let me close this. So I'll open in eViews first of all, then I'll show you on Stata. And I'm going for unstructured, undated, 54 cars. So 54, quick, empty groups. And I'll be just copying the information. I'm doing the comparison of price. Price, call it price. I've got dummy variable. Dummy variable, I'm calling it row test RT. And I'm just putting the values, dummy variable, row test values. These are the values I have told you how to apply the if command. And here my data is copied on eViews. Here I've got this price and this is dummy variable. And if I have to run the regression, I'll go for simple regression. I'll go for this price C, and I'll go for DV row test, nothing else. And as I go for OK, I've got this regression output. And if you remember my discussion, I told you that we'll be paying attention towards the coefficient of dummy variable. Let me write it again and a little more neat way. So what I'm saying, y is equal to beta 0 plus beta 1 dummy variable. So dummy variable is nothing but one type of independent variable. I'm looking forward to whether this is significant or not. Beta 1 is equal to 0 and H alternate. Beta 1 is not equal to 0. This is what I'm trying to test. And I'll look at the p-value right now, and accordingly I'll be able to make the judgment. So if I look at the p-value, look at the p-value of this. This is 0.02. 0.02 is less than 0.05. 0.02, this is 0.02, 0.0235, which is obviously, this is 0.0235 is less than 0.0500. So I'll say that p value is less than 0.05. So my null is rejected. Null is rejected. So null is rejected significant. So now my conclusion, if you remember, I was just discussing if null is rejected, as in the case it is happening, then I'll say there is significant impact of road score on the price of the cars. So what is my conclusion with the help of this dummy variable regression application? I'll again do it for some of you. You might have got some issue in following it. So estimate. I've done nothing. I have just gone to quick estimate equation. And these were my data sets. I'll cancel it. Delete. These are my data set. And these two prices I have copied from my Excel, dummy variable and price. And I have just estimated one regression equation. And I'm saying price as the dummy variable, price as the dependent variable, C is the constant, and dvrt is my independent variable. And I have run the regression. I have looked at the p-value of dummy variable, and that is 0.0235, and 0.0235 is less than 0.05. It means p-value is less than 0.05, which means null is rejected. Null is rejected. So b1 is equal to 0, has to be rejected, and then non-zero is accepted. So interpretation, I have written this in advance. If null is rejected, there is significant impact of road score on the price of the car. Same thing I can replicate on Stata. I'll do it for other variable which I have, that is customer satisfaction score. Forums open for question if you have. Otherwise, I'll show you the same thing on Stata. Any question? So I'm taking to you other application, second part of the application which I had. This value score. Again, suppose somebody, some critic says that the customer value score which we gather have got no role in determining the price. It means more satisfied customers is the basis of having high price. Companies charge high because those cars are having high value, high satisfaction scores coming from the customer. If I want to test again, I can go for median application. I have calculated median. This time I have not gone for road test, rather I have gone for value scores. So now, right now, this is the variable of interest to me. And for that, I have calculated the median. This is the median for this. And again, using the if test, if function, I have calculated the values or dummy variable. One application is there in Stata which helps to do this slightly easily. I'll show to you how it can be done. These are the already we have got. So this is the value SC is the, I'll show you here. This is the variable which is of interest. And we want to know that if I divide this value score into above median and less median, the scores which are more than median and scores which are less than median, and I'll give 1 to the scores which are more than median and 0 to the scores which are having less than median. And then I'll again run regression where price will be dependent variable and the dummy variable based upon value score median will be the dummy variable. And then I'll again apply the same thing what I did with the road test score. So here right now, what I'm going to do, I'll be having this null. So y is equal to beta 0 plus beta 1. And right now I'm having dummy variable for value score. And I'll again go for testing of beta 1, whether it is equal to 0, beta 1 is not equal to 0. And if suppose this is coming out to be, it is rejected or null is rejected, then my interpretation, or let me put it this way so that both the options should be visible to you. If I say that, let me write null. If rejected, not rejected. You might have noticed that I rarely use a term accepted, not rejected. So when I say rejected, it means value scores are useful for price, are useful for price. And he'll say no use. That is the interpretation beforehand. And just let me run the test and I'll be able to tell you whether the customer value score is having any impact on the price of the car or not. So right now, suppose I do not have this, value score. I have this already ready with me. If you have seen that median value is 1.335, and if you look at this, this score is 1.99, more than 1.35, so 1. Look at this 1.3, 1.32 is less than 1.335, so it is given a dummy variable value of 0. The same thing we can create in Stata. Let's say, let me create one dummy variable. I'll use a command known as generate or gen. I'll write down the dummy variable and I'm giving the value score as a name. I'm saying equal to, I'll put a bracket. In bracket, I'll give a condition for which I want the dummy variable value score. I'm creating one new dummy, the new variable. You will find that one variable will be created by the name of dv underscore vs. I'm generating that variable. And what would be the variable? I have to give the condition. And the cars fulfilling that condition, this variable will have 1. And the cars which will not be fulfilling this condition, which I'm just going to write, will give this value of this variable as 0. So my condition is we have got value SC So we have value as C, or what I'm saying, it should be more than 1 point. What is the value which we have? 1.335. 1.335. So value score more than 1.335, I have to just put a bracket, that's it, nothing else. What will take, wherever value score is more than 1.335, a dummy variable dv underscore vs will take value 1, and wherever the value score is less than 0.335, dummy variable dv underscore vs will take 0. If I put the, and I can show you, here is the variable, and look at variable will be here. So same variable, if I, this, you will find that this variable and this value SGG and DVVS are same variable, they are having same values. I can show you one more command, br browse command, and I'll show VS, and I'll show you these two variables I'm showing only. Here it is. So wherever value score is more than 1.335, it is 1. And where it is less than 1.335, it is 0. So it means Stata helps me by using this command, to create a dummy variable. And right now I'll be just making the application of dummy variable regression the way I have just explained. I'm running this regression. And right now my dummy variable will be this new dummy variable, which is based upon customer value score. So regression dependent variable will be still same price. And then I'll write down the independent variable which I have just created. That's it. I have to just run this regression. I'll look at the coefficient of dummy variable underscore vs dummy variable. This is the dummy variable, and I look at the p-value. P-value is 0.055. If you remember my previous discussions, I've told you 0.055 can be considered as partially significant or marginally significant. So here you want to be on this side that you want to reject, you want to say that customer value scores are impacting, then you say that 0.055 is marginally in or marginally significant. And if you are of this opinion that you want to prove no, customer value score is not impacting the price, then you say no, it is not less than 0.05, rather it is more than 0.05. And then you will say there's no impact. But just because it is very close to 0.05, so statistician will insist that it is marginally significant. So we will say as an interpretation, we would like to go for, in this borderline situation, that null is p-value is less than 0.05 or close to less than 0.05, and reject the null, and value scores are significantly impacting the price. That is the interpretation. Forum is still open. You want to have any question, I can answer. So I've tried to explain to you dummy variable regression of only bivariate case. Next time when we meet, I'll give you multivariate case, and then we'll close the topic. We'll start ARIMA. ARIMA is a univariate time series application. So here I'll start talking about time series in detail, as I told you. So that is for the agenda for the next session. So right now, dummy variable partly finished. One more caselet, and one caselet I'll give it to you to practice. Mutual funds. Most probably either we'll conduct mutual fund or CEO salary. I'll see to it. Forum is open. Are you clear with the dummy variable application? Yes or no? Sleeping?
Yes, sir.
Yes, sir.
No questions?
Sir,
Yeah.
this is regarding the assignment.
Yeah.
So when I ran multiple
Just hold
regression,
for 2 minutes. Huh? Let people ask questions on dummy variable. When it is done, then I'll come back to assignment. I'll make the floor open again for assignments. Let me finish the class. Huh? Just wait, Ayushi, for 2 minutes. Yeah. Anyone else has got any question on dummy variable? Anyone? Any question on dummy variable? Yes, Ayushi, please go ahead. You had a question. So rest of you can go if you want. Class is practically over. Those who want to ask questions on assignment, please stay. Yes, Ayushi, go ahead.
So I ran, all my tests are getting passed except retest. So what do I do? Like for everything, or reset?
So you hit and try to have the better specification. And even if you significantly improve means if your significance level goes down, let's say it is coming out to be 0.00, it starts coming 0.04, 0.03, then you can say there is some improvement. Try. You might have
Yeah, I
model where
more than 4.5, it was 0.00. For 1, it came 0.01. So should I go forward with that same model?
So you try to compare the models and try to have standard error of regression, which is coming less. So when you compare two models, I told you that you look at the number of significant variables, you look at higher R square, look at the lesser standard error of regression. So use these three criteria along with the diagnostic testing. So if you are in deciding about two models, competing models, and use this criteria, the three criteria, and the number of significant items, high R square and lower standard error of regression, and you can go ahead.
Okay, sir. Thank you.
Okay, it means class is over. So we'll meet after the assignment submission is done. So next week, or most probably we can meet again on 31st. It is possible. I'm requesting this Prakash sir to schedule one more class on Saturday. Okay, so we are closing. Thank you.
Thank you, sir.